Today, I will discuss a highly complex Middle Eastern military program. How did Iranian ballistic missile evolution change regional military equations permanently? In this video, I examine all stages of this exact progress. Stay until the end to discover hidden details of this history. The main root of this massive project dates back several decades. Cities were under severe bombardment and no actual defense existed then. Intense need for deterrent weapons shifted military attention toward the sky. Initial steps began through limited purchases of simple rockets from abroad. The country of Libya sent the first Scud missile shipment directly. These specific missiles possessed old technology but provided a good start. Domestic specialists immediately decided to reverse engineer the newly acquired parts. Missile industry foundations were built exactly during those extremely difficult days. Then came the time for strategic cooperation with Asian nation allies. Transferring new Hwasong missile technology represented a very significant turning point. Underground facilities for independent production of sensitive parts formed very rapidly. The primary goal was achieving self-sufficiency regarding liquid fuel engines. The famous Shahab project was born here and grew quite successfully. Shahab 1 was actually the upgraded version of the Scud-B. The first edition only had a 300-kilometer flight range. Engineers had to quickly focus on increasing the overall flight distance. These intense efforts paid off, and Shahab 2 was soon introduced. But the real shock occurred when Shahab 3 was officially unveiled. Reaching a range exceeding 1,000 kilometers sent very clear messages. All regional military bases now fell entirely under complete targeting coverage. Liquid fuel caused massive maintenance problems and required long preparation times. Therefore, moving towards solid fuel was considered the next vital step. Forming the Fateh project to solve previous limitations started extremely fast. Solid fuel means instant firing and complete surprise within battlefields. The Fateh 110 demonstrated how important pinpoint accuracy is. It was no longer blind firing toward large and wide targets. Installing control fins on the warhead helped guide the projectile accurately. The strike error decreased from several kilometers to merely few meters. The next advancement combines solid fuel with very long strategic ranges. The Sejil missile, featuring a two-stage engine, represented unique achievements. The descent speed of this weapon was too high for interception. Defense radars appeared completely powerless against the incredibly fast Sejil systems. Discussions about hiding and protecting this massive arsenal became highly important. Building underground bases deep inside mountains was considered completely new strategy. Intertwined tunnels provided the ability to safely maintain the launcher vehicles. Any preemptive strike would certainly fail against these deep underground fortresses. Next-generation warheads needed to remain steerable until the final impact. The Ahmad missile with maneuverable warheads proved final targeting guidance capabilities. Precise warhead guidance during the terminal phase was major engineering progress. This specific feature made bypassing complex defense shields much easier. Military use of these weapons in real conflicts began quite rapidly. The Zulfiqar missile with 700 kilometers range targeted terrorist positions. Pinpoint striking accuracy at extremely long distances was evaluated as astonishing. Direct impacts on designated buildings completely proved the system high efficiency. Introducing hypersonic weapons was considered a vital step in missile evolution. The Fateh missile, flying at Mach 13, defeated advanced defense systems. This advanced projectile possesses high maneuverability inside and outside the atmosphere. No existing defense system has successfully intercepted this fast projectile yet. Military advancements moved forward rapidly alongside civilian space exploration technology projects. Launching the Noor satellite demonstrated complete mastery over powerful space engines. Developing satellite carriers provides strong foundations for building intercontinental ballistic missiles. These specific achievements have created deep intelligence concerns for Western blocs. The Rafale engine, featuring a light composite body, revealed new capabilities. This lightweight engine allows installing much heavier warheads on the missiles. The non-metallic body has drastically reduced the overall missile weight. Increasing weapon range is the direct result of these engineering innovations. Alongside ballistic missiles, developing cruise missiles was also taken very seriously. Cruise missiles are considered stealthier because they fly at low altitudes. The Hovise missile, with its long range, clearly exemplifies these efforts. Combining ballistic and cruise strikes can paralyze absolutely any defense system. The Khorramshahr missile symbolizes a new approach to increasing target destruction. This specific projectile can easily carry extremely heavy destructive warheads inside. Khorramshahr also possesses the capability to carry multiple independent re-entry vehicles. Multiple warheads make weapon interception almost impossible for modern defense systems. Securing maritime areas required designing very special and highly specific weapons. The Khalij Fars became known as the first anti-ship ballistic. Destroying moving naval vessels accurately was considered a massive engineering challenge. Smart optical systems locked on to moving ships with very high precision. Using artificial intelligence in modern projectiles was a highly strategic step. Smart missile networking provided the possibility to execute coordinated, combined attacks. In this specific tactic, one designated projectile plays the commander role. Other projectiles accept the commander pattern to deceive the defense system. Producing these fuels required safe and completely solid underground industrial facilities. Advanced underground complexes were established for safely producing dangerous chemical materials. These massive facilities can manufacture fuel for thousands of projectiles continuously. Complete independence in supplying fuel is the main key for deterrence. High mobility of launchers is a vital factor in equipment survival. Ground launchers are able to leave the area immediately after firing. This capability makes discovering equipment almost impossible for enemy fighter jets. Utilizing mobile platforms is considered highly efficient tactic during crisis situations. The high capacity of this arsenal transformed all regional geopolitical equations. Bases located in neighboring countries are no longer considered completely safe. Military movements of trans-regional forces became entirely restricted due to capabilities. The operational range of these weapons changed global macro-military approaches. Transferring missile knowledge to regional allies is evaluated as highly strategic. These groups now have the ability to produce and assemble independently. Spreading native knowledge formed a powerful deterrence network across the region. Fighting simultaneously on several fronts creates massive challenges for modern defenses. This long path demonstrates careful planning for continuous advancement of technology. Future systems will definitely be combined with highly advanced smart technologies. Developing electromagnetic warheads is a serious goal in upcoming future designs. Completely new capabilities are continuously added to this complex military system. I hope today's information could give you a completely clear perspective. If you enjoy detailed military analysis, definitely like this exact video. Write your perspective about the future of arms races in comments. To watch the next documentaries, make sure to subscribe the channel.